is Eric David Rodriguez Orduña with my ID 153139, and this is a brief explanation of what I did in practices at the Profession 1 in UDEC Campus, Universidad de Concepción. The topic is energy management in UDEC Campus considering photovoltaic systems. The description of the project is basically doing a feasibility analysis for the placement of photovoltaic panels. It considers the incorporation of renewable energies, such as the photovoltaics. It also includes reducing emissions of carbon dioxide and reduce the amount of building considering an efficient management of electrical energy. The description basically is to propose 3 buildings at the Concepción campus where to place photovoltaic systems. The objectives are analyze the best places to install photovoltaic systems and doing the proper investigation of technical, economical, environmental and social aspects. The goals to reach in this project were present a report with the full analysis, do a technical study that is basically where to send the panels, the economical aspects such as investments, environmental impact study about trees plant or emissions reductions, doing a social study about the public perception, acceptance and possible visual impact of the panels, and doing a proper energy management to reduce the peaks of energy. For the specifications of the components we used, for the solar aspects we used the Trino Solar and solar panels and inverters. The Sol is 40 kilowatts. We use this because it's the best relation in dollars with the amount generation by square meter. And we use this inverter because it has 5G connection and we can monitor what's happening, and these two work along together really good. And for the peak reduction, we use another bank of batteries from Axitec. We use it because of its high warranty, and for the inverters of these batteries because this works on DC and we need to do the injection in AC. We use also inverters such as Sony Iceland, and we use it because of the same time and it's best, and these values were the best. The regulations to consider for these kind of projects are the 21.118, that's about net billing, and it considers basically on that clients above 100 kilowatts consume, they can implement their own their own electrical generation by any way they can. And these are about the electrical aspects of the result of the generation. Our contributions were that first we did an analysis of the consumptions in the past and what to expect in the future. We can have here seasonality that it's to consider when we try to do the energy management. This is a yearly range, 2017, 18, 19. Then we use different tools such as SketchUp to model the 3D diagrams of the places where we expect to place solar panels. We use the roofs and we misconsider the shadows and objects, and then we fill it with panels using a tool called Scalio. The places we choose are these, that it's a chemical science building, this is mechanical building, this is the library, the architecture and social science buildings. Then we did the feasibility analysis of economical aspects. Here we can see that the gains of chemical science is bigger than the gain of mechanical, even though they are similar in number of panels. It just varies about 20 panels. And here we have a bigger impact because we connect the panels to a bigger or more expensive fee, which gives us a big gains. For the energy storage system for the energy management, the objective is to reduce this peak. Why? Because during this time the fees are 400 more expensive than during this hour. So reduction here impacts more than a reduction there. So as we can see, the consumption reduces drastically from the 6 p.m. to 7 p.m. because in this hour there are no more classes at the campus, and basically the administrative support leaves. So we use the batteries and the inverter presented in the technical specifications, and this is with the batteries we just need to reduce this little area to have a 13% reduction of the peak demand. We also use this methodology for another building. This is for the technological mechanical, and reducing this area will be affected in 25% of the bill. And then the most important analysis that we made was the social aspects. Why? Because the majority of the almost 63% is considered important that the university produces its own energy. These people and their opinion means that if UDEC generates its own electricity, possibly more students will get into the university. And we also have another two curious results, because people in the university think that there might be or there might be not policies to take care of the environment. And here at UDEC, it's a university from very long ago, and some of the buildings are considered monuments. And mostly the people do not care about the monuments because they care about the electricity and they need to care about the environment. So, a majority of almost 90% thinks that it's correct to invest in solar panels. And why? Because nobody thinks that UDEC cares about the environment, as we can see here. These are the results. This is that most people think it's a prestigious university, it has a higher level, it is expensive, it's including, but nobody thinks that it's careful about the environment. Basically, this was all we did. For the learnings we gained was that we did a course about solar panels. We got it, we got the 90% improvement. We also used a lot of these tools, QFIS, because some weather explanations, Explorador Solar to calculate the irradiation, Autodesk to build the models, SketchUp also to build the models, Scale to place the panels, and Tableau to do the data science of the consumptions and the forecast. For the ethics, we follow the E3 the IEE standards for advancing technology for humanity, and we didn't harm another, we assist our colleagues, and we didn't create conflict of interest. And for concluding for the project and the presentation, we want to say that the objectives and goals were reached successfully. The problems we had were solved with the knowledge we had and the resources that were near to us. In the future, a more efficient use of money needs to be done because there might be cheaper components and there might be people that do it for different prices, whatever, and we don't know it because we are not in the sector. We are just proposing. Thanks for everything. That's it.